Okay, good afternoon, good evening, good morning, anytime you watch the video. This is DCE110, Introduction to Computer Design and Drafting. We're still in Matlab. We want to see how we can finish everything and move to the next topic. Now, today I'm going to look at, this moment, I'm going to look at symbolic computation in Matlab. Okay, I'm going to do a little introduction, then we're going to do some practice. So quickly, I'm going to share my screen, and okay, so you can see you are seeing my screen. Symbolic computation toolbox overview. Okay, now symbolic computation. It's part, it's a Matlab provision for us to perform symbolic computation within the Matlab numeric environment. The symbolic math toolbox, was designed to assist us, in solving and manipulating symbolic math expression and performing variable precision arithmetic. Okay. Now, when we say symbolic, you need to understand symbolic. It means that we're not interested in getting a particular value in terms of a figure, okay? Like 1.2, 3 point for something. So symbolic computation will return back values that are close to our mathematical, our human way of solving some equations that don't need, definite number results. Like what we do in differentiation, integration, and when you are doing what we call simplification or formula, when you are trying to find when you are trying to do what we call change of subject. You want to make a particular variable to be the subject of the formula. Okay. We're going to see some examples that will clarify that. For instance, you have x is equal to 2x, plus y, and you want to make y to be, or you want to make x to be the subject of the formula. Okay, subject of the formula. Now it means that you have to collect the like terms, and then you have to make x to be in one side. So in actual fact, you can say, okay, you can say x minus 2x is equal to y. Okay, and then you now say, okay, x minus 2x. Okay, so you're going to have something like minus 1x. That is minus x. So minus x will be equal to y. Now, when you want to make x to be, now you are going to multiply both sides by negative. So you're going to have x is equal to minus y. And so those are the things that you can do. For instance, you have force is equal to mass times acceleration. And then you say F is equal to ma. And I will now say, okay, you want to make the mass or the acceleration to be the subject of the formula. So you can say, okay, well, wow, now multiply both sides by probably m. And then you have, divide both sides by n. And you have f over n is equal to a. So a will now become f over n. Now, this is when we will need symbolic computation. So Matlab provides symbolic computation toolbox to handle that. The toolbox contains hundreds of symbolic functions that leverage the MU-PAG engine for a broad range of mathematical tasks such as differentiation, integration, linear algebra operations, simplification, transforms, variable precision, arithmetic, equation solving. Yes, solving equation. Okay, going to solve probably, some equation that we're looking at, maybe productive equation, maybe simultaneous equation, all those things. So symbolic math tool software includes the MU-PAG language, which is optimized for handling and operating on symbolic math expressions. So it covers common mathematical tasks, and it also covers specialized areas such as number theory and combinatorics. Okay. You can extend the built-in functionality by writing custom symbolic functions and library using the MU-PAG language. Now, MAPU also, is compatible with the symbolic math toolbox software that they're using. So now let's look at symbolic objects. Now, symbolic objects, it's talking about special data type in Matlab that are introduced by the symbolic math toolbox software. They allow you to perform mathematical operations in the Matlab workspace analytically without calculating numeric values. Okay, that's all I've been trying to explain. You can use symbolic objects to perform a wide variety of analytical conditions. So before you can actually perform symbolic computation, you must define the objects as symbolic. You must use a keyword sim to define that variable. If you don't define the variable as symbolic, then it will not be used in symbolic computation. So you can use symbolic objects to perform a wide variety of analytical computation. As we have mentioned, differentiation, including partial differentiation, definite and indefinite integration, taking limits, including one-sided limits, summation, including Taylor series, matrix operations, solving algebraic and differential equations, variable precision arithmetic, integral transforms. All these are areas that symbolic objects can be, applied when you want to do symbolic computation in Matlab. So symbolic objects present symbolic variables, symbolic numbers, symbolic expressions, and symbolic matrices. So example of symbolic objects, the symbolic variables, symbolic number. Any number can be defined as symbolic. It should not be taken as the normal number to become a symbol. So symbolic expressions, symbolic matrices. Now let's look at symbolic variables. To declare variables x and y as symbolic objects, you have to use the command sims. Okay, sims xy. Then you can manipulate the symbolic object according to the usual rule of mathematics. Okay. For example, x plus y. The answer will be 2x plus y. Okay, it should not be looking for you to put what is the value of x before it computes. Just give you so 2 plus x plus y will give you 2x plus y. Now you can create formal symbolic mathematical expression and symbolic matrix. So these are things you can get from the Matlab website or Matlab handbook manual. Now let's look at symbolic numbers. Symbolic Math Toolbox software also enables you to convert numbers to symbolic objects. So to create a symbolic number, you use the sim command. Now it's going to be only one. Excuse me. Okay, sorry about that. Symbolic Math Tool, symbolic numbers. Symbolic Math Toolbox enables us to convert numbers to symbolic objects, and it will cease from being a number. That means it cannot be manipulated with our normal mathematical operators like times, minus. When it becomes symbolic. Now, let's look at the example. To create a symbolic number, use the sim command. The other one, you use zims. This one, you use zim. For instance, A is equal to zim in quotes, in bracket, then quote 2. Okay? Now, if you create a symbolic number with 10 or fewer decimal digits, you can skip the quote. Okay? It will take it. So, if it is, if you create a symbolic number with 10 or fewer digits, you can skip the quote. 10 or fewer digits. If you have more than that, you must put the quote. Okay, let's say the following example is between standard double precision Matlab data and the corresponding symbolic number. So let's look at symbolic the Matlab command square root of 2. We return a double precision floating point number. Answer will be 1.4142. Now, on the other hand, if you calculate a square root of symbolic number, if we say A is equal to square root of C, then you put the number in bracket and then you get the precise symbolic result, which is 2 raised to power half. So this will be treated as symbolic because it will not give you the actual computational value in figures. So this will just be symbolic, 2 raised to power of half, instead of giving you 1 point this. Okay. Symbolic results are not indented. Okay. Matlab standard double precision results are indented. Difference in the output form shows what type of data is presented as a result. To evaluate symbolic number numerically, use the double command. So when you now say double A, it will now turn it back to numerical answer. Okay. You can also create a rational fraction involving symbolic numbers. Sim 2 over sim 5, it will give you 2 over 5. Or if you say sim 2 over 5, just give it like this more efficiently because they are the same thing. Now, Matlab can also perform on symbolic fractions, differently than it does on standard numeric fractions. So these are the things you can go through in the handout that you have. So you can see 2 over 5 plus this, you can have this. But when you say Zim 2 over 5 plus Zim 1 over 3, you are going to have 11 over 15, like you are finding the LCM and all that. Now, creating symbolic variable and expression. Now you have to do this using Zim command. You can create symbolic variable and expression. X is equal to Zim X, then where A is equal to Zim, put it in bracket, in quote. Create symbolic variable X with the value X assigned to it in the Matlab workspace, and a symbolic variable A with the value alpha assigned to it. So this is what you see. But you can also use Zim also. Alternative way to create a symbolic object is to use Zims. Okay. Sims S, okay, A is equal to Sim alpha. Now you can use Zim or Sim to create symbolic variable, but let's look at the differences. The Zims command does not use parentheses and quotation marks. Okay, can you see that? These are the differences. The ZIMs, when you say ZIMs, you should not take parentheses, that is bracket, and quotation mark. It can create multiple objects with one call. So that's the power of ZIMs. You can say ZIM X, comma, Y, comma, whatever, okay? Now, serves best for creating individual single and multiple symbolic objects. Okay, take note of this, very, very important. Does not use parentheses and quotation marks when you are using it. Can create multiple objects with one call. Serves best for creating individual single and multiple symbolic variables. Now let's look at the ZIM command. It requires parentheses and quotation mark when you are using it. When creating symbolic number with 10 or fewer, you can skip the quotation, okay? Marks. You can skip the mark. But you cannot, create multiple symbolic objects. Create one symbolic object with each call. Now, ZIMs can create multiple objects with one call. Can you see that? Now, it serves best for creating symbolic numbers and symbolic expression. Serves best for creating symbolic objects in function and scripts. So, now, in symbolic math toolbox, pi is a reserved word, so we cannot use it for creating symbolic objects. Creating symbolic expression. Look at the example here. You want a symbolic element to represent the Goldie ratio. Rho, R ratio O is equal to ZIM. Because it's code, then you put quotes. Then 1 plus square root 5. Then achieve this goal. Now you can perform real mathematical operation on the rho. Now you can now say F is equal to rho raised to power 2 minus rho minus 1. Then you're going to have this. It's going to substitute the value of rho and evaluate them symbolically, symbolic evaluation. Now, suppose you want to study the quadratic function this. F is equal to ax squared plus bx plus c. Approach, you can say F is equal to ZIM. Then you quote it and then you put that there. We assign this as variable x. To assign this to variable f as symbolic. However, in this case, symbolic matrix does not create variable corresponding to the terms of the expression a, b, c, n. To perform symbolic math operation on f, you need to create the variable explicitly. You have to say a is equal to sim a, then b is equal to sim b, c is equal to sim, then or simply you can use the sims. Sims a, b, c, x, and then you can now enter this. When you enter this, then it will. So to create a symbolic expression that is a constant, you must use the ZIM command. Take note. Do not use ZIMs command to create a symbolic expression that is a constant. So that's another thing that ZIM can help us to do. Anyone that is a constant, you can use only ZIM to do that. So now, creating symbolic object with analytical name. ZIMs AB, F is equal to A plus B, and returns F is equal to A. So that's the answer, okay? Because if later you enter Sims F, you're going to say F is equal to F. So now you can create symbolic variable made up of matrix. So creating a matrix of symbolic variable. You can have this ZIMs A, B, C, then A is equal to A, B, C, colon, semicolon, C, A, B, semicolon, B, C, A. So you're going to, when you type the A, it's going to give you this as symbolic, matrix. And this, okay, you can now say sum A, the first row and all the columns. So that is ABC. It's going to give you ABC. So the first row, then that takes you the first ABC. Say A, the first row is equal to, is trying to test equality. Is it equal to the sum of A all of the second column. This is the first row column. This is the second column. All the rows, second column. Then all the. So you see that the sum are equal. A is equal to answer is equal to 1. Can you see that? So you see A, this, and this is this, and this. They are equal. You can see using is very similar to using regular matrix, Matlab numeric objects. Now we can also have symbolic numbers. This is A is hill 3, hill. This generates 3 by 3 Hilbert matrix, which are these values. By applying sims to A, then you have some A, then to change them to symbolic. Finding symbolic variable in expression and matrix. Determine what symbolic variables are present in an expression, use the SymVar. Okay. To determine what symbolic variables are present in an expression, use the SymVar command. Look at this expression here, sims A, B, N, T, sims, okay, covers all this. A, B, N, T, X, Z. And then F is equal to Z raised to power N, then G is equal to sign in bracket A times T plus B, close bracket, and then suppressing the output here. Then you can find the symbolic variable in F by entering SymVar F. The answer will give you N, X. SymVar, you can find symbolic variable in G by entering this sim. G will give you A, T, and B. Okay, A, B, and T. So that is about that. So let me quickly look at another important thing we call performing symbolic computation. Now, this is the area that will involve, differentiating, integrating. So when you want to apply Matlab to differentiation and integration, you can perform symbolic computation with that. So this we can, this manual here, you will see symbolic expressions, simplifying and simplification, substituting symbolic expression, estimating precision of number to symbolic expression, to symbolic conversions, differentiating symbolic expression, integrating symbolic expression, solving equation, finding a default symbolic variable, creating plots of symbolic function. So I will just rush through this. You can go through this manual on your own. It's on the module website, a module site, so that you can have a reference. Now, you can simplify symbolic expression with this. So when you say simplify F, it will simplify. So look at this here. Now, symbolic simplification is not always so straightforward. There is no universal simplification function because the meaning of a simplest representation of a symbolic expression cannot be defined clearly. So different problems require different forms of the same mathematical expression. And knowing what form is more effective for solving your problem, the particular problem, is very important. So you need to know which form we can, and that is by practice. You can choose the appropriate simplification function. For example, look at this. To show the order of polynomials symbolically differentiate or integrate polynomial, can use standard polynomial form, and then we have this. Look at this sim x. So it has changed all this x into symbolic variable, and then you now say this. Now say you should expand f. Now this expansion gives x raised to power 10 minus 1. Okay. The factor simplification function shows the polynomial root. When you say sim x and then you have this, then you say factor g, then it will give you the roots of the polynomial. Then Honor can help you. Representation, so can help you with this. You can see more in the Matlab help. Substitution, you can substitute in symbolic expression. Subs command can be used for that. Sims s, then enter the command subs. When you type this and you enter the command subs f, 2, it will substitute 2 into the value of x, and then it will be able to give you the answer of f. Okay? So that is what substitution we do. You say, okay, in f, substitute 2 for what is not known. That is what is not. So, for instance, let me see if I can quickly run this. Let me see if I can quickly run this. As an example, I'm going to do, let me stop sharing. Okay. Okay, let me close this. Okay, let me bring the command window out. Okay. So, okay. Now I want to just do subs. Okay, look at what it has brought out. Okay, can you see that? Now, let me show. Let me remove this. This. Can you see what it has brought? I don't want to suppress the output of that. Okay. So it has done that. Now say put. And now say, okay, substitute that. Now what it's going to do is going to put 2 in times x times 2 raised to the power 2, that is 4. 2 times 4, that is 8. Minus 2, and 3 times 2, that is 6. Plus 1. Sorry. Okay. That is 3 times 2. That's 6. This is 2. It's about 4. This is not giving me what I expect. Okay, so that substitution is just replacing the substitution. What it's doing now is, so the value of x is equal to 2 in the symbolic expression. Now it puts 2 here. Now, yes, what it does here is, it first of all, say 2 times express, you have to do this one first. 2 raised to the power 2 is 4. Then 4 times 2, that is 8. Now, 8 minus 2 times 3 times 2, that is 8 minus 6. That is 2, then plus 1, 3 is correct. Okay, that's just, you have to test just to be sure that it has done what we expect it to do. Now, substituting in multivariable variable expression. So what has happened here is that if you can see what I'm sharing now, let me see okay, if you see what I'm sharing now, you will see that we say 2 times 2 raised to power 2, sorry, minus 3 times 2 plus 1. That's what it's going to give you. That's what I've just done. So which is correct, okay? So I just want to be sure. Okay, now you can substitute in multivariate expression like this, okay? You can substitute one symbolic variable for another. So let me quickly rush to, I want to just jump to differentiation, multiplication of numeric to symbolic conversions. It's also here. You can go through this one. Now, differentiating symbolic expression. This is where I want to quickly rush to because of our time. You can read up the other one. With the symbolic math software, two buffers where you can find derivative of single variable expression, partial derivative, second and higher order derivative, mixed derivative. What you just need is you have to define your symbolic variable, which sims s, then f is equal to sine x raised to power sine s power 2. Then differentiate f. It's going to give you the differentiation immediately. 2 cos x and So now let me quickly do some of the things we like to. Let me say sims. Let me see whether you are. Okay, let me be sure you are seeing. Let me just say sim sim x, okay? Then I say f is equal to s to the power 2. Now I want to start with what you already know. Now, when you want to differentiate s squared, okay? If I say diff f, can you see? It's 2x. So this is the division of x to the power 2 is 2x. The same thing. If I say f is equal to x raised to power 4, and I say div f is 4 times x raised to power 3. You can see that 4x raised to power 3. So these are simple things you can see. Let's see. Okay, now we can also do partial derivatives like that, and you can have all these things. These are what you can try on your own using your Matlab environment. Now let's quickly look at. Now you can take derivative twice with this because you get all this we're talking about. Now let's look at integrating symbolic expression. The same thing. You can have symbolic integration, indefinite and definite integration, integration of multivariable. Just like you are integrating, for instance, if you want to integrate 2x, you get the value of x. Okay. For instance, I say sim x is already defined. Then I say yes. Okay, I say f is equal to s is a 2x. Is 2 times x. Okay. Now I now say int f. You see now it gives in x is equal to 2. So you can see differentiation is, integration is opposite of differentiation, like that. So you can see how it works. It's quite interesting. Okay, so with that you can quickly run through this. So find indefinite integral, you can have this f of sine x. F is equal to sine x, and then you try to do this. The same thing with these ones. You have all this. So it's quite interesting. Can have definite integral. So in Matlab you can not find a closed form of an integral. If Matlab cannot find it, then you can. Then if the int function cannot compute that, Matlab uses a warning and return the int function of an answer. So explicit integral cannot be found because it's not able to do that, and then it now give you this. Now we can also use Matlab symbolic computation to solve equation, algebraic equation with one symbolic variable, algebraic equation with several symbolic variables, system of algebraic equation. These are things that can be done in Matlab. Algebraic equations with one symbolic, you just say sim s, and then you now say solve. You use the solve, and then it will give you the values 1, 2, 3. By default, the solve command assumes the right side of the equation is equal to 0. But if it is not equal to 0, you have to put it in quotation marks around the equation. So when you do it is put it, if it's not equal to 0, then you have to make sure that you put this equal statement, put the value it is equal to, and then you put it in quotation mark, and then it will give you the answer. Okay, algebraic equation with several symbolic variables like sims xy. You can see this. F is equal to 6 times x to the power 2 minus 6 times x to the power 2 times y plus y plus x times y raised to the power 2 minus x times y plus x plus y raised to the power 3 minus y raised to the power 2. Then, with respect to a symbolic variable y, it can solve this. Just say solve f with respect to y, and it will give you this answer. Okay, let me just run this very briefly. Time is running. Okay, let me be sure the Matlab is on. Okay, I want to make sure you're seeing it. Okay. Okay. Now with this, I will just run this with. I want to demonstrate. I want to solve this with respect to y, symbolic variable y. I've already declared the xy. Now I will just type solve. Okay. I will just type solve f comma y, and then it will solve it. That is the solution to that with respect to y. Okay. So let me finish up with this. So if you don't specify any variable, you get the solution of an equation for the alphabetically closest to x variable. For the complete set of rules, you can check the Matlab help. You can also solve sum of equation. Okay, x, y, z, x comma in angle bracket, then solve z is equal to this. Then you're going to have x equal to this, y is equal to this, and z equal to this. Then finding a default symbolic variable. Okay, zim xt, g, then zim var g1, then answer is t. That is the default. Sim x sx tx, g is equal to x, then zim var g1, then tx. Now you can check more on the Matlab help with Simva. Now creating plot of symbolic function. This is quite interesting. I have to do this. It's quite interesting. You can create different types of graphs, including plots of explicit function, plots of implicit function, 3D parametric plots, surface plots, and with this you can do that with with EZ plot, SymX EZ plot, and then hold on. Then see, let me just quickly run this. My time is running. I want to be sure that you are following. Okay. Okay, look at, it's going to come up. Okay, look at this is the plot. You can see the plot here. Okay, so this is the plot of this function or this equation. Okay, now hold on means let it stay instead of appearing EZ plot. We just do this and you have that. So quickly, let me finish up on this. You can try this on your own. The hold on command retain the existing plot, allow you to add new elements and change the appearance of the plot. For example, you can put X label, Y label, and all this on it, and then you have all these things. So if you put all this one in your script and you run it, you will see what is going to happen. Explicit function, X is equal to 3 minus 6 times X to the power 2 plus 11 times X minus 6. This will give you, this is known as this, okay? And you will have this. So it will plot it with EZ plot. EZ plot is very good in plotting function plots, symbolic function plots, explicit and implicit and 3D parametric plots, surface plots also. Very, very powerful. So you can try this on your own. You will really get a lot of very good output. You can see this. Okay, let me just quickly run this so that you can see. This is implicit function plot using this sims sy. This is the f x to the power 2 plus y to the power 2, everything raised to the power 4 minus x to the power 2 bracket minus x to the power 2 and y to the power 2, everything to the power 2. Then is a plot set f minus 1 to 1. So that is the range. Okay, then let me put this. Let me just run this as a Matlab command. I can put it in the script, but I just want to see it as Matlab command. Okay, so you can see it's going to try, and you can see how it puts this. Now, if you study this code, you will see that you have the X label, which is this, X as this, Y label, Y as this. Then you can see minus 1 to minus to 1. That is, creating equal for both sides. Okay, and then this is implicit function. This is title, grid on. Now, if you want to probably change the color, may be able to do that later. But for now, just look at it. This is the output of this. Thank you very much. Bye for now. Okay, bye for now. Bye for now. This is almost the end of the whole thing. You can see this is the end of it. Thank you very much. So this is just the end of it. Bye for now. So you can try this on your own and see how it goes.